All right, everybody, welcome to Chapter 5. In this chapter, we're basically going to be proving identities and using formulas, and it's just going to be a plug-and-chug type of a deal. As much as you dislike me saying this, I just treat this as a big game, and we just use these identities that you see on this page. Most of these you have used or should recognize already. They are actually not on your salmon sheet like yours says, but you know, just know that the reciprocal identities, when it's cosecant, it's 1 over sine, and so on down the line. You really want to recognize your tangent, cotangent, ratio identities, just because they really help throughout this process. And then our Pythagorean identities, this one we know is sine squared plus cosine squared is 1. That's not on your salmon sheet, but these two are on the top left corner of your salmon sheet. And those are basically the only ones that you'll see in this section, but your salmon sheet will be used for the rest of the chapter. When we prove these things, hopefully I have ingrained it in your head at least to this point that we cannot touch the right side. So what we got to do is recognize what do I got to do to the left side to make it the right side. And if you do not know anything, the first thing we want to do is change everything into sines and cosines. So if you're stuck, do that. So sine theta is sine theta. And cotangent theta, if you look on the previous page, is just cosine theta over sine theta. And since we're multiplying, anything on the top and bottom can cancel. And in this case, it's just cosine theta left. And that's what I wanted on that side. So I win. Okay? So smiley face, whatever you want to do to make yourself all happy. But you never want to touch the right side. Always write what it needs to be on the left side. So likewise, on number 2, I cannot touch the right side. Now, it's kind of like a game. You got to look at it. You know, some of you might look ahead and say, okay, cosecant theta I know is 1 over sine theta. That's fine. You can recognize that, but I want you to write cosecant theta on the bottom over here when we're done. So I don't know anything, so I'm going to go 1 over cosine theta, which is what secant is. Cotangent from the previous problem I already know is cosine theta over sine theta. And what's nice about that is now these guys cancel. I have 1 over sine theta. And then that becomes, now I recognize that that's there, but I need you guys to write cosecant theta right here, and then we win. Okay? So that's the simple ones, the ones that hopefully you guys could have maybe done without me doing anything. All right. Now the fun part starts. All right? I cannot touch the right side, but what I recognize is that on my left side I have tangent plus cosine, okay, one little term, but on the right side I have a set of parentheses. The only way parentheses shows up is if you factor something out. Okay, that's the only way you can make it work, because if you went the other way, you would distribute that back in. So I know I need a sine to factor out. Well, the only way I'm even going to remotely be able to do that is if I have a sine in both of them. Okay, and when I change it to sines and cosines, I do not have that. So I know I have to get a sine out of there. Well, in order to do that, I'm going to have to multiply top and bottom by sine theta. The reason I do that, just like I said before, is I want to be able to factor that out. So I'm just going to write it in order here. And now you notice that there's a sine on the top here and a sine on the top there. So I'm going to factor that out. And if I factor that out, what will be left? And the first one, it'll be 1 over cosine still on the bottom, plus cosine theta on top, sine on the bottom. More times than not, good things happen when you guys make the correct step and recognize, okay, I got to take the sine out. Now what's secant? It is 1 over cosine. And what is cotangent? It is cosine over sine. So that was the trick there, was to multiply, okay, the top and bottom by sines, because I had to recognize that I needed sine in both terms to factor it out. And that's kind of the process. You got to look ahead, see what your answer is, see what's different, and see how we can go through the steps to get there. This one's basically the exact opposite. Notice that I have parentheses here, and I don't on the side that I want it to look like. Okay? So if I'm going to do it this way, I'm going to end up distributing in the sine. So I'm going to go sine theta secant theta plus sine theta cosecant theta. Okay? Once I distribute it in, then, well, you could have gone sines and cosines before you start too, but now I'm going to change it all to sines and cosines. So I have sine theta times secant is 1 over cosine theta. plus sine theta times 1 over sine theta. Now wonderful things tend to happen. The signs cross out here, okay? And what is sine over cosine? It's tangent theta plus, they're gone, all I have left is a 1. And that's what I wanted, okay? So once you recognize, okay, I have parentheses here and I don't over there, I get rid of them. And then once again, if you make usually one correct step, good things tend to happen. Ooh, yuck. Let's get to some of these interesting ones. Okay. If you ever have it, and this is the only way I'll ever show you this, but cosine to the 4th power theta minus sine to the 4th power of theta, all right, you're going to want to factor that. This is a difference of a perfect square, okay? So no different than if we'd have something a perfect square and you're going to factor it out, so like an x squared minus 9, you guys would go x plus 3, x minus 3, right? Well, on this particular case, when it's cosines and sines, you got to take essentially the square root. Well, all that is cosine squared theta plus sine squared theta. And then it'll end up being cosine squared theta minus sine squared theta. Okay, I had to write a little bit bigger, so my line now is going to be there. Okay, and all of that's over cosine squared theta. Now, why is this helpful? By the way, this is what it's going to be every time. Just recognize the difference of perfect squares. It just takes a matter of practicing. But on your very first slide, what did sine squared plus cosine squared equal? 1. So this part's actually gone because it's 1. Okay? That is a huge thing to recognize because this obnoxious looking numerator is now not as scary. All right? We now can simplify it down to here. And what I recognize is that my answer is a 1 minus tangent squared theta. Well, I recognize that if I split this fraction, I'm going to have cosine squared theta over cosine squared theta minus sine squared theta over cosine squared theta. What I mean by splitting a fraction is that denominator goes under each of them separate. And now I have 1 minus sine over cosine is tangent even if it's squared in both scenarios. Just I make it tangent squared. And you're done. Okay? So the big one to do on this one is if you ever see the 4th power minus another 4th power is to factor it out as difference of perfect squares. And then it becomes not so bad. All right? I think there's 3 more. So this is the same battle. It's just the denominator is a little bit more difficult. So I'm going to move this up to give myself more room. And you're going to want to factor that out. Okay, so I know that that top, just like last time, but since sine's first, is going to end up being sine squared theta plus cosine squared theta. And then sine squared theta minus cosine squared theta. All right, so then this is where my line is going to go just to give myself more room. And this is going to be all over the sine squared theta times cosine squared theta. All right, just like last time, and every time you deal with it, that part's equal to 1. Okay? So then I just like to rewrite whatever's left up here, and I have sine squared theta all right. Now how do I deal with this? Now I have secant squared minus cosecant squared. Well, right now I have one term here, but here I have a minus sign, it's 2. So if I ever see that I go from one term to 2, I'm going to have to split the fraction. So I'm going to do the same thing I did last time. Sine squared theta is the first part. I'm going to put that over my denominator. And then minus, I have cosine squared theta over the same denominator. That's what I mean by splitting the fraction and why it goes from one term to 2 terms. All right? Now something nice hopefully will happen. So I have sines and sines, and then a cosine and a cosine. All right, super. What's left? 1 over cosine squared theta minus 1 over sine squared theta. And I need a secant squared minus cosecant squared. Well, that's kind of neat because I know that 1 over cosine squared is secant squared. And then 1 over sine squared is cosecant. And you're done. Okay? So once again, we had to recognize a couple things this time. The whole splitting it out or factoring out the 4th powers, that is 1. And then going from one term to two terms, you're going to have to split the fraction. And then more times than not, something nice does indeed happen. Okay? All right, number 7. Once again, I see, let's see, what do we got? 2 terms, and we're making it 1 term. Okay? So in order to combine or add 2 things together, you need a common denominator. I instantly think that in my head. So I'm just going to change it to sines and cosines first. So I know that that's sine theta over cosine theta plus, this is going to be the exact opposite. All right, and the only way I can combine those is if I have a common denominator. So I need to make a common denominator. If I have cosine here and sine there, I need the other one in each fraction. So I have to multiply, and the only way you can add or put something in is if you multiply. So I'm going to go sine theta over sine theta on the left one, and then I'm going to go cosine theta over cosine theta on the right one. This allows me to have a common denominator in each. So now if I simplify this out, I have sine squared theta on top over my sine theta cosine theta plus cosine squared theta on top, sine theta cosine theta. Now with a common denominator, I now can shove them together. All right, and I'm going to use a different color here. So sine squared theta plus cosine squared theta over that common denominator. And then what's nice about this is now what do you guys notice about the top? Sine squared plus cosine squared is indeed 1. So I would have 1 over sine theta times cosine theta. And I need a secant theta, cosecant theta. Well, 1 over sine theta is cosecant theta. And 1 over cosine theta is secant theta. And I don't care what order they come in because multiplying can switch. So I know that that is indeed the same exact thing. Okay? But I do want you guys to write this last step down there. All right? So that is 7. And then the very last one. This is a doozy. This is a long one. Okay? So I'm going to try my best to make it as painless as possible. But what do I notice right away? I am adding 2 fractions together. And I end up with 1, okay? So 2 terms to 1 term. The only way that works is if you do what? You need a common denominator, okay? So in order to do that, you need to make yourselves get a common denominator. Well, I have a sine theta here and a 1 plus cosine theta there. In order to make this work, I need the other in there. So I'm going to go sine over sine on this one, and then I have to multiply 1 plus cosine theta on that one. 1 plus cosine theta on this one. Okay? So I end up with sine squared theta on top over, so sine theta 1 plus cosine theta. Alright? This one. Okay, what crazy stuff we got going on here? We have to multiply essentially 2 binomials together. Okay? So what you're going to have to do is actually FOIL this crap out. Okay, so we got to go 1 times 1 is 1. Cosine theta on the outside. Plus cosine theta is the inside. Plus cosine squared theta. Okay, so that part's going to be there. All over that same common denominator. Ooh, boy. Now what happens when you guys have the same common denominator? You now can add them all together. Okay? So I'm going to kind of cheat here just to save myself room. All I know is that these 2 right here, cosine plus cosine, do you guys agree is 2 cosine theta? I hope. And then if I'm adding, what do you guys know about sine squared theta plus cosine squared theta? I hope you recognize that that is indeed 1. Okay? So I'm going to write that first. Sine squared theta plus cosine squared theta is 1. Plus, what's left? This one plus, what else is left? 2 cosine theta. So I kind of jumped steps there, but I can add these together. So I'm just looking at the top. Sine squared plus cosine squared is 1. This original one is there. And then 2 cosine theta is there. All over my common denominator. Okay. Now what else do we have? If I add together the top, I have 1 plus 1, which is what? 2 plus 2 cosine theta over, what else do we have here? Oh, I didn't put sine theta, so sine theta, there should be a theta there. 1 plus cosine theta. All right, now is where I kind of get stuck, because I need to look at my answer. I need a 2, just a 2 left over. Well, I have multiple 2's, and I need just a cosecant theta, which means I recognize that this 1 plus cosine theta needs to go away. Okay, so it's got to cancel out. I'm going to go one step to the right because I'm losing room. I recognize that I need a 2, and I need a 1 plus cosine, so I'm going to factor out a 2. What happens? What's 2 divided by 2? 1. Okay, 2 divided by 2 there is 1 cosine theta. That's neat because now when I rewrite this, I had to recognize that the 1 plus cosine theta is needed to cross out. Okay, so it's just looking ahead and seeing steps that you need to do in order to have the 2 show up and that guy cross out. Now I have 2 over sine theta sitting here, which I know is just 2 cosecant theta. Whew. So there it is. That's the last one. We're going to come to class. We're going to practice these things. Here's the assignment if you guys want practice right away. And I hope that you have a wonderful day.